Welcome to the next topic on transactional database. What is a transactional database? A transactional database generally comprises of a file where a transaction is represented by each record. A transaction typically has a unique identification number which is represented as transaction ID or trans ID, and a list of transaction items which are represented as products bought in a shop. The transactional database may have additional records connected to it containing other sales related information such as the transaction date, the customer ID number, the salesperson's ID number and the branch where the sale took place, and so on. Let us see an example below. A transactional database produced by us for this series for Start Incorporation, the fictional company with one record per transaction. Transactions can be stored in a table. A fragment of a transactional database is shown in the figure below. This has been depicted below. The sales table is a nested relationship from the relational database point of view because a set of items is contained in the attribute list of items ID. Since most relational database systems do not support nested relational formations, the transactional database is normally either stored in a flat table, in a table-like format, or unfolded into a standard relationship in a format similar to that of the table items being sold. This has been depicted in the diagram below, which contains the transaction ID and the list of items that has been sold in all electronics company. You may be requested as an analyst for our database. Show me all the products bought by Sandy Smith, or how many transactions are containing the item ID 13. It may take a scan of the entire transactional database to answer such queries. Am I right? Yes. Suppose you want to dig deeper into our information by wondering which products have been sold together well. This kind of assessment of market data would enable you to bundle item groups together as a strategy to maximize the revenues. For instance, knowing that printers are frequently bought in conjunction with personal computers, you could give a costly printer at a discount to clients purchasing selected personal computers, hoping to sell more expensive printers. A periodic data recovery scheme is insufficient to respond to such queries. However, transactional information mining systems can do this by recognizing regular item sets, the sets of products that are often sold together. One might be interested in knowing what is the difference between transactional and relational database. Majority of the relational databases supports transactional database operations. Transaction database meant for transactions, but whereas relational database can be a transaction processing system and analytical processing system. Transaction refers to the usage of a database, while relational refers to the way in which a given database stores data. A transactional database, or another term for transactional database, it is also called as operational database, could be a relational, hierarchical, or it can be an operational database also. A transaction database supports business process flows and is typically an online real-time system. The way in which the data is stored is typically based on the applications. Companies often have multiple transaction databases. An operational data store, in short it is called as ODS, is an integrated view or compilation of transaction data. Then you get into data warehouse databases where the transaction data is optimized for querying, reporting and analyzing the activities. And how can I clean up this information? Data from the real world tend to be incomplete, noisy, or it can be incoherent. Methods of data cleaning seek to fill in missing values, level out the noise while identifying outliers, and correct information inconsistencies. This involves several methods. The first is missing values. Imagine that sales and client information need to be analyzed. You may notice that for several characteristics such as client revenue, many tuples have no recorded values. How can you load for this attribute in the missing values? A few techniques are available here. The first and foremost technique is ignore the tuple. Usually, this is performed when the class tag is missing. What is a class tag? It is nothing but assuming classification is involved in the mining assignment. The second method is unless the tuple includes several characteristics with missing values, this technique is not very efficient. If the proportion of missing values per trait varies, it is particularly poor. The second method is called as manually fill in the missing values. This strategy is generally time consuming and may not be viable due to a big number of missing values. To fill in the missing values, use a worldwide constant is the third method. This replaces all missing attribute values with the same constant such as a label like unknown, or if missing values are substituted by unknown, then the mining program may erroneously believe they generate an exciting concept as they all have unknown values. Therefore, while this technique can be managed, it is not a foolproof technique. The next method is use the mean attribute to fill in the missing values. For instance, you consider that customers' median earning is 56,000 rupees. Use this value to substitute the revenue value that is lacking. The next method is called as use the mean attribute for all samples belonging to the corresponding class as the specified tuple. Replace the missing value with the average income value for customers in the same credit risk section as the specified tuple. For example, if customers are classified according to credit risk. The next method is use the most likely value to fill in the missing value. This can be determined using regression, inference-based instruments that use a Bayesian formulas or induction of a decision tree. For example, you can build a decision tree using the other customer attributes in your data set to predict the missing income values. We will discuss about decision trees, regression and Bayesian inference are outlined in detail. The most efficient approach is the last technique which I had described earlier. This utilizes the information from the current data which is said to predict missing values compared to the other techniques. By considering the values of the other attributes in estimating the missing income value, there is a greater likelihood of processing the relationships between income and the other attributes. It is important to note that a missing value may not involve a data mistake in some instances. For instance, applicants may be asked to provide their driving license number when applying for a bank account. Applicants who do not own a driving license number may typically leave this field blank. Forms should therefore enable respondents to identify values that are not relevant. It is also possible to use software routines to uncover other null values. Ideally, the null condition should have one or more rules for each attribute. The laws may indicate whether nulls are permitted and how to handle or transform such states. Fields can also be left blank deliberately if they are to be supplied at a subsequent stage of the business process. Therefore, almost we can attempt our utmost to wash the information after it is included, excellent database design and data entry processes should assist in the first location to depreciate the amount of missing values or mistakes. What's the purpose of a database? A database is intended to store and perform associated information operations consistently. Modern databases can support information store activities while prioritizing the data stored integrity. Each procedure or transaction includes at least one autonomous work unit that may include reading or writing data to the data stored. When performing these operations, the database must be maintained in a coherent state to prevent problems with other data store customers. The integrity of the stored data is retained and transactional mistakes are avoided by ensuring that various entries in the database are recorded as individual or atomic transactions. Now let us look into how these database transactions works. A transaction from a database consists of any unit of work performed within a database management or an equivalent system. The procedure must be against a database and handled from other operations as an autonomous operation. A transaction's main two aims are depicted in the figure below. First aspect is providing reliable units of work that are able to recover correctly from failure, and the second major aspect is it is used to keep a database consistent in all situations to include system failure, unexpected execution corruption and supporting numerous incomplete operations on the database. The procedure must support the key principles of operation to be atomic, coherent, isolated and durable in order to be considered a database transaction. If a transaction is not finished owing to the demands of database transactions, the required result of the procedure will not be realized. Now, let us look into the operations of transactional database. A transactional database is a database management system which, if not correctly finished, supports rolling back transactions in the data stores. A transaction interruption may result from energy loss or a data store disruption in connectivity. Most of the databases currently in use support operations. These activities may consist of one or more queries or statements about information manipulation. Since data integrity and consistency are critical to adequate operations of the database, most transactions use structured query language, in short it is called as SQL, or a language similar to SQL to perform activities using the following patterns. Step 1. Initiate the transaction. Step 2. Execute the provided set of data queries or manipulations. Step 3. Commit the transaction and complete it if there are no errors. And the last step 4. If an error occurs in the transaction, roll it back and end the operation. Transactions are often stored in multi-user database using an XID, or another term it is called as transaction ID. In practice today, businesses have introduced transactional databases to include the use of nested and multi-level operations in a variety of respects. One such thing is called as structured query language, SQL. SQL is a programming language developed to handle information that is stored in a relational database, or in short which is called as RDBMS. Originally, the language was based on tuple, relational calculus and algebra relational. SQL involves language for data definition as well as language for information manipulation. The language's main range involves activities for inserting, updating, querying, deleting, modifying and creating schemes and controlling data access. Although SQL is a declarative language, a number of procedural elements are also included. It was also the first language used in relational databases, and in 1986 it became an ANSI standard. 1 year later, SQL became an ISO standard. ISO stands for International Standard Organization, and has been upgraded to include fresh features several times since. What are the transactions carried out using SQL? In essence, the SQL language is essentially transactional. There are a number of SQL standard database applications which are in use today that stretch the language and enforce an explicit declaration of start transaction. But this action merely deactivates the declaration of auto commit. No activities on the database will become noticeable to other data store users after this stage until the system processes a commit declaration. Now let us see what is the meaning of rollback. It is also possible to execute a SQL rollback declaration that will undo any job on the system since the last successful transaction. Now let us look into the transactions using SQL. In essence, the structured query language is essentially transactional. There are a number of SQL standard database applications in use today that stretch the language and enforce an explicit declaration of start transaction. But this action merely deactivates the declaration of auto commit. No activities on the database will become noticeable to other data stores users after this stage until the system processes a commit declaration. There is another transaction which is called as rollback. It is also possible to execute a SQL rollback declaration that will undo any job on the system since the last successful transaction. The statement rollback and commit will complete a transaction and begin the next transaction. If the database management system uses a start transaction declaration to disable the auto commit function, it will be re-enabled. The following statements are also used for alternative SQL implementations. This include begin, begin work and begin transaction. Next, let us look into the ACID property, which is an important property in the case of relational database management system when it involves transactions. Transactions are completed by commit or rollback SQL statements, which indicate a transaction's beginning or end. The ACID acronym defines the properties of a database transaction as follows. A stands for atomicity, which refers to a transaction must be fully complete, saved, another name for saved is committed, or completely undone, which is represented by rollback. A sale in a retail store database illustrates a scenario which explains atomicity. Examples of them are the sale consists of an inventory reduction and a record of incoming cash. Both either happen together or do not happen. It's all or nothing. The next concept is called as consistency, which is represented by C in atomicity. The transaction must be fully compliant with the state of the database as it was prior to the transaction. In other words, the transaction cannot break the database constraints. For example, consider a database which contains a table of phone number column. This can only contain numerals. Then, consistency dictates that any transaction attempting to enter an alphabet letter may not be committed. The next letter I, which represents isolation, transaction data must not be available to other transactions until the original transaction is committed or rollback is represented by isolation. The last letter durability, which stands for D, represents transaction data changes must be available even in the event of database failure. This concept of atomicity is represented in short by a diagram. Now let us look into the next concept, which is how do distributed transactions work. Databases can now support distributed transactions against various host or application computers. The demonstrated ACID properties are still implemented by distributed transactions. However, this is performed across various data stores or systems. These systems can consist of a multitude of non-classical databases such as file systems, messaging systems, databases and other applications. Typically, the distributed transaction will coordinate services to guarantee that the suitable scheme applies all elements of the transaction. If any of the transaction components fail, what will happen? The transaction will be handed back across all of the affected systems. Now let us look into the important concept, which is nothing but the advantages and disadvantages of transactional databases. Flexibility is the main benefit of database operations. User of the database can alter certain data without touching delegate or isolated data. It is possible to accomplish the interface and rules for manipulating the data store without altering the general system structure. In addition, database transactions enable users to have an enhanced capacity to retrieve history when the information is stored in a restricted setting. Finally, there is minimal danger of data loss owing to scheme or energy failure owing to coherent information shops supplied by transactional databases. Now let us look into some of the disadvantages of transactional databases. This include possibly less readable data because some implementations have only an information as insert only function. Furthermore, there is less chance or capacity for many end users to alter data within a transactional database. This places a higher burden on ensuring information accuracy before performing a database transaction. Now let us look into the risks from transactional databases. The mining of our activity information like this poses several hazards. I am just going to concentrate on a small portion of it. Many companies are involved in risk management. Consider a health insurers, for instance, take the risk that their insured will not get sick. Employers take the risk of their workers' ongoing performance. In evaluating the hazards connected with the transaction, these types of organizations must trade off the price of collecting data with the value of the data and make the best company choice. Historically, the cost of gathering some information was simply too high to include in the calculation of risk, so these companies chose to transact without the information. They did not have the strong transactional database known instruments. Governments can also depend on transactional database data to tax you for operations you have participated in while on vacation outside the tax-free state in which you actually reside. For example, an insurer does not need the individual's private health records to determine the health of a potential insured. They would simply have had to follow the applicant around and see what they ate and evaluate their lifestyle in general. That data could then be used to calculate danger. They are not entitled to this data and you do not need to reveal it, but they may choose to collect this data by themselves if it is done in public. Now I'll conclude the transactional database by summarizing the entire concepts, which involves Exchange Server, which is a robust system based on proven transactional database technology. Although the underlying database technology will shift in a future version, exchanges database previously known as JET will continue to do the work. Even in a monumental crash in an exchange setting with proper backups and disaster recovery processes and infrastructure in place, there is no reason why this should spell the company's disaster. Native exchange technologies provide support at all levels. High availability options such as clustering to protect against downtime and options for disaster recovery such as standby continuous replication and dial tone database recovery enable relatively speedy return to production in many cases. There is also a plethora of third-party applications and hardware not covered in these chapters that make HA, which stands for High Availability, and DR, which stands for Disaster Recovery Operations, easier. Thank you. I hope you would have understood this concept of transaction database.